quick introduction. So I'm Chris Fregly, Principal Solution Architect for AWS. I specialize in generative AI, as I think most of the world has recently. Antje, should I introduce you? Or do you want
I think I'll manage my introduction. Hi, everyone. Welcome. I'm a principal developer advocate for generative AI at AWS. Today with a little bit of a thin voice, so Chris will do more of the talking. Super excited here to host 2 exciting talks today.
Yeah, and the MOOC that Antje is showing here, Deep Learning AI, we actually partnered with them a couple months ago. We built a pretty awesome massive open online course MOOC around generative AI, specifically LLMs, and we actually do talk about RAG in the course. We do have a couple experts here on the line, one from AWS, so that's Giuseppe. Yeah, Giuseppe, do you want to say hello?
Sure. Hi, everybody. My name is Giuseppe Zappia. I'm a senior solutions architect here at AWS. Yeah, excited to be here.
And then we have Roie from Pinecone, old buddy of mine from the Databricks days. He was a customer. I was at Databricks, and we actually just reconnected, I guess, after like 9 years or something crazy. So good to see you, Roie. Do you want to introduce yourself?
Yeah, good to see you, Chris. Hi, everybody. My name is Roie Schwaber-Cohen, and like Chris said, I'm a staff developer advocate at Pinecone. Very excited to be here and talk to you all about RAG.
Yeah. So this is what we're calling our RAG special. Antje, I think we may actually end up doing some more RAG talks next month. Is that true? I think RAG is hitting in the life cycle of generative AI. I think more and more people are starting to realize the importance of RAG. So I'll potentially have another part 2 special next month, but we'll see as that comes together. I'll try to find it.
Yeah, and let us know in the chat, folks, if you're interested in more topics. Let us know what you want to hear about, and we can definitely do more RAG. All right, with that, I'll stop my screen share and hand it over. I think anything else, Chris, you want to add? Otherwise, I think we're good to start.
Yeah, no, we will record until the speakers are done. So even if it's the top of the hour and they're still speaking, we'll continue. We'll try to give, I think, about 25 to 30 minutes per speaker, but if you have to go over. And it's going to be a few slides, and then we're going to very quickly dive into code as well to both speakers. So this is more of a code-based webinar. So yeah, Giuseppe, go ahead.
Yeah, like you said, I don't like a lot of slides, so I'm going to try to keep them to a minimum. Yeah, thank you for having me, guys. So our talk today is going to be on Retrieval Augmented Generation with LangChain. So quick agenda, just the things that we're going to talk about. We're going to talk about some of the challenges that people run into when they're using large language models. A super brief overview of what RAG is, or Retrieval Augmented Generation, what LangChain is, what the different components of a Retrieval Augmented Generation workflow, and then we'll shoot right into a relatively deep dive code-driven demo showing you how you can get started. So I'll show some of the foundational components. So some of the challenges that we run into when we're trying to use large language models is that they are really powerful, right? A lot of us, or all of us, already have seen what GenAI and large language models are capable of. But when you start to get into specific use cases for your specific scenario, they're not usually tailored to address those types of requests or those types of data sets. So it's a challenge where the responses that you're getting out of the large language model are a little bit more generic. You might run into issues with those responses. A large language model is kind of limited to the corpus of data that it's been trained on. We see a lot with some of the big models that have come out. They have a time horizon where if you try to ask it a question about something relating to current events, maybe even something as early as yesterday, it just doesn't know. Sometimes even going back a couple years. So if the model hasn't seen the data, it can't give you an answer based on stuff that it hasn't seen. Sometimes you'll see the topic of hallucination come up where the model just doesn't know, so it tries to make something up. So we try to account for that in our prompts and tell it to not hallucinate, but then we just get a bunch of I don't knows. So that's another challenge that we run into. One of the techniques that we've used to try to address this, the kind of time horizon the amount of data that a foundation model is seeing is through a concept of fine tuning. So we add additional data specific to our use case to try to tweak and adjust the weights and parameters on the model to work better for our data. That could be challenging. It could have a high total cost of ownership, TCO. And we also have to keep doing that over time. So as our data changes or as our model changes, we have to account for that by rerunning fine tuning or rerunning retraining to allow our model to have access to that new data or to bring our data to that new version of a model. So these are some challenges that we run into that could either affect the performance of our models or affect our bottom line as far as the total cost of ownership of the model that's running our applications. So one of the techniques that we talk about to address this is a concept of retrieval augmented generation. You may have seen it a lot in kind of all the blogs that have been coming out recently. In the past, I want to say like 4 or 5 months. It's gotten bigger and bigger and bigger because of some of those challenges that we run into. I think cost is probably one of the driving factors there, where everybody's trying to justify the use of GenAI, and the more that we can keep costs down, the better that number looks. So what we do with retrieval augmented generation is just a technique where we take data that's external to the model and we incorporate it in our prompts to the foundation model to get a more tailored output. That's kind of the long and the short of it is we're not going to fine tune and inject data into the model. We're going to bring context to our prompts and then inform the large language model so it can give us a high quality output. So how is it different? So if you look on the left here, you have like what a standard prompt kind of looks like for Llama 2, where we tell it just answer the question that I've provided you. If you don't know the answer, just say you don't know and don't make up an answer because we don't want our models to hallucinate. And we just provide the question, right? It's a zero-shot question there. And that's great, but the model relies on what it's seen in order to give you that response. Sometimes it may work, sometimes it may not. Sometimes the data may be stale. So what we try to do with RAG, or Retrieval Augmented Generation, is we change our prompt slightly. So in the beginning, we say, use the context provided to answer the question. The rest of it is the same. And then we provide a context block in our prompt, which is going to incorporate a bunch of contextual information that we want the model to use when formulating its response. So we're letting the model do what it's good at as far as like manipulating language and things like that, and providing it data to give you a solid response back. It's different than the concept of like a few-shot learning where you're providing examples of what you want. Here, we're just providing contextual data. So what's LangChain? LangChain is an open source framework. Its purpose is just to simplify the development of applications that are using LLMs. It has a bunch of different wrappers for all the common components of a large language model based application. So we'll see in the example, we'll see wrappers for large language models. We'll see them for vector stores. We'll see them for our embedding models. There's a whole bunch of different components and wrapper classes and things like that LangChain provides in order to streamline and kind of abstract out some of the heavy lifting of the application development for LLM-based apps. It also provides additional functionality around chaining in memory. It has agent capability. We'll talk about that in a couple minutes or in a second. Just to reduce the complexity and the amount of code that you have to write to get a GenAI application out the door. So these are some of the common components that you're gonna see when you're using LangChain. You're gonna see in the demo today the first 5. So I'm not gonna get into memory agents and tools, but we have document loaders for being able to load documents in and manipulate them so that we can generate embeddings and things like that. There's wrappers for the different types of vector stores, so that you have a place to store the embeddings of your documents and of your queries, or when you're generating queries. There's this concept of prompt templates where we could generate a template of a prompt and inject data into it. So you saw in our previous example, we had a prompt template that showed the context block and the question block. And it just allows us to streamline and add some consistency to the way that we're asking questions to our models. There's a bunch of different interfaces for LLMs. So you'll see today one for SageMaker models, but there's a lot of different ones for some of the service-based models as well. And then you have chains. So chains are ways to combine your prompt templates, your LLMs. You could potentially add agents into the flow to allow you to simplify the act of asking questions, getting responses, things like that. Memory is kind of pretty self-explanatory. It allows you to kind of save the state of the conversation. So if you have a conversational AI or something like that, the memory allows you to generate responses based on what has been asked previously. So you can ask kind of like iterative questions. Agents are really interesting, and they're a little bit deep for a short conversation that we have here, but they use large language models to decide on different activities that they can perform using the last one, which is tools. So tools are a bunch of like tools in your tool bag of generating or pulling data to allow an LLM to make maybe more robust responses. So they could be go search Google, go look up stuff in a database, go run API calls and things like that. The tools are the activities that happen, and the agents are the things that decide what to do. But like I said, we're not going to hit those last three. We're going to focus on the building blocks. So a RAG workflow kind of has two basic stages to it when you're getting started. One is document ingestion. So this is where we take a corpus of our documents. We are going to generate what we call embeddings. So we use an embedding model, a different ML model, to vectorize the document, and then we store it in a vector database. So we take sections of, I'm going to show you Amazon letter to shareholders, for example. We're going to break that document up into different chunks. So you have small manageable pieces of documents. We feed them into an embedding model. It then generates a bunch of vectors, and then we store them in a vector database. So the first stage is all about populating the vector database so that we can then run queries against that database to get the context that we need to ask questions to our model. So this is kind of where the magic happens after the fact, where we have an application and we want to ask questions, right? We have a chatbot in here or something like that. Our user on the left goes and asks a question. So that's our first step there to our GenAI application. Our GenAI application is going to use LangChain as an orchestrator. So it'll pass that query down to the orchestrator. The next step is we generate a query embedding. So we take our question and we generate vector for it, or a set of vectors for it, using our embedding model. And now from there, we can take the vectors that are generated by our embedding model and run vector-based queries against our vector database. And we'll talk about that in a lot more detail when we start talking about Pinecone. But what we're able to do there is determine what the relevant pieces of information there are, and then return a set of context documents back that we'll then use as a prompt, part of our prompt to a large language model. So we grab the context of those documents, or you'll grab several context elements from a bunch of documents. You feed them into your prompt template. You feed the original question back as well. And now the large language model knows the question that you asked the application to begin with, as well as a whole bunch of contextual information around what's relevant to answer with. And then from there, we'll generate a response back to our application from the large language model based on that context. So without RAG here, you would have just had to ask the large language model a question and hope it knows the answer. In this case, what we're trying to do is we're trying to inform the model with context so that it can answer with the information that we want, the way that we potentially want it to respond. So let's get right in. So we talked a lot about what RAG is, and I want to show you it in action. Cool. So hopefully you could see my screen here. So I put together inside of SageMaker Studio. So you're going to get kind of like a little bit of an AWS flavor to the way that I'm approaching this problem. We're using SageMaker models and some other things, but you could do this in a standalone notebook using your own resources as well. What we're going to do here is we are going to take a set of Amazon letters to shareholders, and we're going to process those documents and then ask the large language model questions that it will answer based on the context of those documents. So the Amazon letter for shareholders, for those who don't know, every year we publish our CEO, used to be Jeff Bezos, now it's Andy Jassy, publish a document kind of recapping the year, some successes, some challenges, some ways that Amazon has addressed those challenges and things like that. So what we'll do is we'll ask questions based on that. You could bring any data to this. It doesn't have to be this specific scenario. So we're gonna, for our use case here, we're gonna use a couple different components. We're gonna use LangChain as the framework for orchestration. We're gonna use an in-memory database called Feist. I'm using this just because it allows us to, I could run it right in my notebook here. You have a whole bunch of different options for that. Pinecone being one of them. You use Feist, you could use ChromaDB, you could use OpenSearch, you could use pgvector. There's a lot of different options that you have, all with their different strengths. We'll also grab PyPDF for just processing some of our PDF documents. So I will actually run this in real time, and we will do the whole thing where we don't run live demos, but we're going to do it. So we'll install our packages here. We will grab a set of PDF documents here. So these are publicly available documents. I'll apply a little bit of metadata to them just for more advanced scenarios that we could run in the future. And then we'll store them locally. What we'll do here is one of the things that we do as part of the documents that are generated is our CEO always attaches the first letter to shareholders to every new one. So the 2022 one has a letter to shareholders attached at the end from 1997. What we're going to do to make sure that our documents aren't biased towards that 1997 output, we're going to remove those pages and then regenerate those PDFs. So now we have some clean PDFs, and now we're going to go through that first step of document prep. So we can see that LangChain provides us a couple different things. To simplify the processing of those documents. It provides different text splitters and document loaders. So we're going to use a PyPDF doc loader to load the PDF into memory, and then we'll use what we call a recursive character text splitter to try to break up that document into manageable chunks. So the recursive text splitter splits on like double new lines, single new lines, then spaces, and things like that, to try to maintain as much of the contextual, the semantic value of the context, because those are the typical delimiters that determine what's semantically connected and what's not. It'll do that to try to break up into chunks that we'll define as a particular chunk size with an overlap. So what we do is we break a document into chunks, but then we stagger them over the top of each other to maintain context across chunks. So you don't have a document that's two chunks and they're completely split. They're two chunks and they slightly overlap, and you can dictate kind of what that overlap should be. In this one, I'm using a 512 chunk size with a 100 overlap. They can be whatever you choose. So we'll do that. We'll take our text splitter. We're going to split all those documents. So we took 4 documents, and we ended up with 25 pages, but we ended up with almost 300 chunks. So now when we start to run our queries over it, we have a wide variety of little pieces that we can grab based on our question. All right, so then we can deploy a model for embedding. I've already deployed the models to save time here, but you'll deploy 2 different models. You'll have one that's an embedding model that generates vectors based on input text, and then you'll have another one that's an LLM for generating those responses. In here, you could use SageMaker Jumpstart as a way to grab a model to deploy. You can get it right through the SageMaker Studio console if you're a SageMaker user. There's a whole bunch of different options that you have. I'm using mini LM L6 to do that. And I will run here. And I already have it deployed here. So all I do is grab the endpoint name. So we have a model deployed here that we're going to use to generate those vectors. So now the next area is to create and populate that vector database. So what we're going to do is we generate a content handler that's specific to our embedding model of understands what the input value, the input structure is of the input JSON, and then what the output looks like, so that we can get those inputs and outputs. So that's what our transform input and transform output functions are in here. And then from there, we generate a content handler object, and then we use one of the benefits of leveraging LangChain is LangChain has a bunch of wrappers for a whole bunch of different types of implementations. So being that I'm using a SageMaker deployed model here, LangChain supplies a SageMaker endpoint embeddings class. So all I have to do in order to get my embeddings model to function inside of LangChain is deploy the model, provide the endpoint name, the region, and how to handle the content. So this piece that you see here for the embeddings is all I need to write to be able to pass input to the embedding model. All right. So from here, we can start to leverage some of the other capabilities of LangChain. Namely, it has wrapper support for a bunch of different vector databases, Feist being the one that we're using here, but it does support Pinecone and a whole bunch of other options. So we're able to take our documents that we generated, the embeddings model that or the embeddings pointer to the SageMaker model that I have here, and simply run a from documents against the Feist class. So it knows, here's my documents, here's my embeddings, here's where I need to store, here's the type of store that I need to use. And it does all the heavy lifting for us. So under the covers here, it's taking all of those document chunks, passing them into the embedding model and generating vectors. And in 30 seconds or so, I've generated a vector database with all of those vectors already in it. So from here, I'll run a query against it just to validate that it's functional. So the question I'll ask is, why is Amazon successful? Probably something that's common to see inside a letter to shareholders. And we also get a bunch of different helper functions in here for all the different database wrappers. So one of the types of helper functions that we have here is run a similarity search and respond with the score. So we'll run it and I'll talk about it. So you see a bunch of different content chunks here, along with the metadata for those chunks. But you also see the score value, and it's kind of ambiguous. The score is the L2 or L squared value for the distance between the vectors. So, in a multi-dimensional space, you have vectors that you've generated for your embeddings. We've generated one for the question. And what the database is trying to do is find the distance between those vectors, and the vectors that are the closest together are the most relevant content. So you can see here, they vary a little bit between, this first one is 0.39, the next one's 0.55 and 0.59. So the smaller that value, the closer those vectors are together, the more relevant the content's supposed to be. You can also use this metadata to run queries to filter out data. So maybe if I only want to query based on 2022 data or a specific document or something like that, I can supply a different metadata to my query to scope down the corpus of documents that are candidates for being matched against. So we have our vector database. We're able to query it and get data context out of it. Now we're going to create a prompt. So this prompt should look very similar because it's the one that you saw in the original example. Just says, use the context provided at the end. Use the context provided to answer the question at the end. If you don't know the answer, just say that you don't know and don't try to make up an answer. We have our context block here. We have our question block at the bottom. And then we've supplied what the input variables are for the prompt template. Pretty straightforward. So then we have a prompt template. We don't have a large language model yet. So we have to build a wrapper out for that. So that's our next step. We're going to prepare our LLM. We're going to build the content handler pretty much the same way that we did for the For the embedding model, it's just a little bit different because the model's different. So this one's set to use Llama 2. So we have the input and output functions here, and we're just going to build a content handler exactly the same way that we built it before. So it's the same thing here. I had the option to deploy a model using SageMaker Jumpstart. I've already deployed it, so I'm going to just kind of skip through the section. We'll supply its endpoint here. So I have a SageMaker model endpoint that's got Llama 2. I use 7B just because it was super small. So if we publish for people to use that, it's more cost effective to use. But you could use 13B or something else. You can use a completely different model if you want to. And just like we had in the embeddings section, there is a SageMaker endpoint wrapper for our large language model that allows us to pass in some additional pieces of information. So we pass in our endpoint name, we pass in the AWS region that we're working in, and then I could start to specify, the maxi tokens, the top P value, temperature for, how creative you want the model to be, some additional attributes for Llama 2 that requires us to, specify that we accepted the ULOAD before we can use it. And then now we have an object, a large language model object that points to our SageMaker endpoint, just like that. So we can actually query it right out of here. So what we'll do here is we'll see what the response looks like just from the LLM with no augmentation to it. So the question that I asked is, how has AWS evolved? It's going to take that query. It's going to pump it directly into the large language model using the default prompting. I didn't do any specific prompt engineering on this. And we will get a response back in a second. And you could see that Amazon Web Services evolved significantly since its launch in 2006. Here are some key milestones. And this is not a bad answer. There's a lot of good contextual information here, but it's very similar to just what you'd get out of a Google search, right? It's here's the things that happened. And how has AWS evolved in the context of a shareholder letter is very different, right? Like you want some of the inside scoop around what has AWS done to evolve? Like what are some of the unique things that AWS has done? Not just what has happened, right? What has the services that they've deployed? That's not exactly what we're looking for. So while the response is good, it's not as good as it could be. So what we'll do is now we're going to leverage LangChain to provide the context to the prompt and see if we can get a more tailored response back. So here we'll invoke it. We're going to create a chain. So LangChain has a bunch of different chain types. We're going to use a basic one for QA retrieval, where we basically take our LLM, we take our prompt template, we stuff the context inside of the prompt, and then we point it at a vector store to retrieve data or to retrieve context based on the query. We'll have it return the source documents just so that I can show you the outputs and how what it used to generate those responses. And then we supply our prompt template. So I can do that real quick. And then I'm going to ask it, I can ask it a series of questions here. So I can ask it that question of how has AWS evolved? And I'll ask the other ones while we wait so that we can save ourselves some time. So you can see here, the question, how has AWS evolved? The large language model is actually telling you that it's using the context provided in its response. And some of the ways that AWS has evolved is through rapid innovation, through long-term investment, through expanding our service portfolio, through profitability, which I guess is helpful, and adapting to changing customer needs, which is a tone and the content that you'd expect to see out of a shareholder document is what has AWS done to be successful, not necessarily what has happened that was successful from AWS. And then you could see I've split out the response here just to make it readable. But these context documents in the bottom are all the pieces that we've used to supply into the context prompt to generate the result. So you can see there's 1, 2, 3, 4 different sections. We could have done a bunch of different things to adjust the number of responses and things like that. But all of these different pieces participate in generating this response. You could see long-term investments and delivering new features, over 3,300 features. And you can see that those data points are even included in our response. So by taking that context out of our vector database, matching it up via our query, we're able to grab content that's relevant to our question and answer the question with that context. Same thing for why is Amazon successful? What are some of the challenges? The shareholder letters are going to contain those nuggets of information, and we're able to extract those and provide those as prompts or as data to our prompt. How was it impacted by COVID-19? All these things are relevant. And then when you're done, you could just clean up your endpoints and you're done. So you could see how the amount of code that I had to write to build this application. Now, obviously, I didn't build a front end and some of the other things that you might include in there, but the meat of the GenAI application is there in maybe less than 100 lines of code in totality. So that's one of the benefits that LangChain brings to the table, is all these wrappers and all these abstraction layers to allow you to get your GenAI applications out the door faster. Let me switch back to slides. I'm going to share the slides to Chris and Antje. So I put a couple references in here as well. Just a link to where you can find LangChain. AWS has provided some documentation on how you can potentially use RAG. There's a blog post that's out there around retrieval augmentation using Jumpstart in RAG. So yeah, thank you for your time, everybody. If there's any questions that I need to answer, I'd be happy to do so.
Hey, yeah, great job, Giuseppe. Yeah, lots and lots of questions in the chat, so I might point you over there. I think a couple big ones are, common ones about the chunking and does that cause any bias if there's overlap? And can you just tell us anything you know about the chunking? Might answer some of the questions.
Yeah, I mean, I think the overlap is important to maintain connectivity between the different chunks. I don't necessarily see it providing bias, because you're going to do it consistently throughout the document. So you're not going to weight certain sections of the document more so than others. It's just to maintain kind of maintain continuity of the thoughts throughout all the chunks.
And I guess if you don't know, someone mentioned that maybe, well, here you're only using years, 2020, 21, 22. So obviously that's the only data that's being searched. But if you did need to search back to 1997, how would you do that? You would just load in more years.
You would load in more documents. There's different techniques for how you want to return the documents. So you can say, give me the top 10. There's a different technique called MMR, where you can try to ensure that your documents are very different from each other, but still relevant. So, think of a Google search where you run it and all of your answers are exactly the same. If you use MMR, it will re-rank the results to provide you relevant documents that provide different ways of talking about that topic. So you'll have a lot more, instead of having 4 documents that say almost exactly the same thing because they're all really close, it'll grab documents that are close but are different. So you can get some variety there as well. You could also do some filtering, like I said, with the metadata queries and things like that, to maybe time box a query or do something like that.
Oh, right. Because when you load these docs, you can provide metadata, right? Like the year of the document and
depending which store you use.
Aha. All right. Yeah, Giuseppe, one last real quick question. People are dying to get access to that notebook, including myself. because I can.
All right, yeah, I'll share it to you guys after we're done here, and yeah, we'll get it out there.
Okay, yeah, and then I'll post it to the meetup along with the video for this. So, okay, yeah, Antje, anything from you, or should we jump over to Roie?
Yeah, we should jump over. Giuseppe, great talk. If you could just skim through the questions here and maybe answer a couple more that we didn't get to in the chat. And then Roie, I think you were monitoring the chat as well. And you can maybe pick up some that are relevant to Pinecone and that fit your narrative
Yeah,
in the talk.
I'll try and pepper some of them into my
Perfect.
talk. Giuseppe, first of all, that was an awesome talk, and I feel like there might be a little bit of an overlap between our talks. And so I think what I'm going to do is go over my talk pretty quickly, and then jump into a little bit of code where I'm again doing something very, very similar to what you're doing, but instead of doing it in a Python notebook, I built a full stack TypeScript application with Next.js, and I hope that will help clarify some of these things that have been asked in the chat. And it'd be great if, because I'm not seeing the chat while I'm presenting, if anyone wants to like pop in with a question. I think it would be probably more helpful if we stop and ask questions and just go over the talk uninterrupted. Anyway, so what I want to talk about that we can maybe like go into a little bit more detail is like what embeddings are, how they work in the context of a vector database and in the context of RAG. So the basics is something that Giuseppe already talked about. Embeddings are essentially just numerical representations of relationships between discrete objects like words and documents and other types of objects like images in high dimensional vector space, right? And that basically gives us the ability to ask a model given two vectors, what is the distance between them, right? And those vectors have some meaning, right? Like they're not just like just any kind of vectors. They're vectors that pack a punch, right? They encapsulate some meaningful data within them, right? And so if we look at a very simple visualization of this concept, right? When we in this example, we have like days of the week, right? And we'll see that basically what happens is in an embedding model is that concepts that have some sort of semantic similarity are essentially clumped close together compared to concepts that are far apart from one another, and those are essentially different from one another in the semantic sense. And so what basically we get from using these embeddings is contextualized meaning, right? It's like we can say these words don't only exist with as concepts in and of themselves, they exist within some context, and the embedding models don't only understand the meaning of those words, they understand the meanings of the context in which those words live, right? So in this example, we have, where's the Bank of England and where is the grassy bank? And how does a plain bank, the word bank repeats in all of them, but its meaning is completely different. And so within the embedding model, we'll expect to see these embeddings basically are going to live far away from one another within vector space. And then conversely, if we have two sentences that have that use completely different surface forms, like the bees decided to have a mutiny against their queen and flying stinging insects rebelled in opposition to their matriarch, even though the surface forms are completely different, the meaning is captured, and because it's very similar, those two sentences are going to live sort of very similar, very close to one another within vector space. And that comes in very helpful within the context of, again, RAG, because for the most part, RAG is used in applications that are of semantic in nature, right? Like there's a chatbot, a user is going to communicate their intent by asking questions, and then we're going to want to rely on the semantic information that lives within that question to retrieve the most relevant information. Now, why are vector databases important in this case, right? And like, what's the difference between, say, FIAS, which is what Giuseppe demonstrated, and a fully fledged vector databases? So there are several differences, right? The key difference is scale. Fias, for example, is a vector store that lives in memory, and for the most part, you are limited by what it can do within that context. It doesn't come built in with the ability to easily update its own index, delete items from the index, etc. It doesn't behave like a database does. And so what vector databases are there to do is to basically give you all of the benefits that you get from traditional databases, but be basically native to the vector data type. And so vector databases are there to help us manage vectors at scale. And like I said, insert, update, delete very quickly. And that's important when you're dealing with applications that have to be real time or near real time. Vector data, like again, this is not news, but like Giuseppe said, you have a query vector, and then once you have a query vector, you can produce a set of similar vector to that vector based on some similarity metric. And that was something that was asked again and again over in the chat. Pinecone and other databases allow you to choose which similarity metric you're going to use to retrieve your vectors. You can choose from cosine, Euclidean, and dot product similarity. And that sort of, in most cases, will depend on the model that you're using. If your model was trained using cosine, you'll for the most part use cosine similarity to retrieve from the database. It's basically a mirror to what the internal representation of the model is, right? When we're saving embeddings in the vector database, we're basically mirroring exactly what the internal representation of the model is. And one of the perhaps more powerful features that might seem like, whatever, but it's kind of actually quite important, is that a vector database allows us to associate some metadata with each one of our vectors. And it's important for several reasons, right? One is that, like mentioned before in the very end of the talk, you could do all sorts of optimizations based on basically doing like either time boxing or any kind of like subquery that kind of breaks down the index into smaller chunks and into smaller parts, and then doing your query on those subsets of data. But more importantly, in my opinion, right, it allows us to, again, associate metadata that goes beyond just like the content of the embedding itself, right? So, for example, if I'm embedding a whole bunch of documents, I can associate those documents with either a URL or some other reference that will be helpful for me, again, in the context of RAG, to produce a meaningful result, right? And I'll demo that in a moment. In that context, Pinecone specifically is a high performance vector database. It's made most specifically to deal with large scale scenarios. It's very easy to start using, but that's not where the journey ends. Like the whole purpose of building the product as it was built is so that it scales up to hundreds of millions and billions of vectors, while still maintaining low latency queries and high speed writes, as well as not blowing up in terms of cost to maintain and to operate. Okay, so very quickly, because this is something that I think Giuseppe went over quite well. This is like the architecture for any kind of semantic search architecture. So anything that has like a vector database in its backend, and this doesn't actually limit to only semantic search. It could also include image search and other types of search that uses embeddings in them. Usually, it's a two-track flow where we start with some content. That content gets embedded using our embedding model, produces vector embeddings. We have metadata that's associated with each one of those vector embeddings that we create. And that's very important because, again, we can associate, we are so essentially manually not or programmatically associating this metadata with the vector embeddings. we then save those embeddings and the metadata associated with them in the vector database. And then when it's time to query, we embed the query as well, and then use the vector embeddings that were produced to get back a query result that would include both the embeddings and the metadata. And I don't have very much to add to what was already talked about by Giuseppe about RAG, other than to say that, again, like, vector databases deal with embeddings, but not only with embeddings, right? They're sort of a bridge between the world of embeddings and then the world of structured data, right? So because we can associate any kind of metadata with our embeddings, we're then allowed to do all these different complex operations that would make our responses down the line more sophisticated, more informed, and we don't have to rely just on the context of the page that we got back. So, for example, if you've seen, any kind of the type of responses that you get from a Bing or from like a Bing chat or any of these types of chatbots, you can get back references that include URLs, that include any kind of rich information that goes beyond just the context, the page content of the response. And I think that's incredibly helpful. But then again, after that's done, we still can take content, inject it into the prompt, or stuff the prompt with that information, and get back a response that's much more informed. Again, nothing new here. This is exactly the same type of situation as we saw before, except for now results go back, we get stuff in the context, and then get sent back to the LLM, and then from the LLM back to the application. Okay, so these are all the slides that I have. I'm going to stop sharing this, and I'm going to start sharing some code. Is that it? Yes. Okay. Okay. Actually, you know what? Before we get into the code, I'm going to share my browser again, because what I want to show is what this application is. Can you give me a thumbs up or something if the screen is okay?
Yeah, we see your UI here.
Okay, perfect. Okay, so what we have here is a very simple chat. I'm going to just clear these indices. You can say hi, it will say hi back to me. And then I have these, oh no, come on, demo gods. Come on, demo gods, don't fail me now. Just 1 second. Just 1 second. This worked, I swear. It should take a second to fix. And if not, we'll just jump into the code. Okay. So, oh no. Nope, this is buggy. Okay. So we're not going to show that. Sorry about that. Instead, we're just going to show the code, and we can discuss it separately. You can probably find it live somewhere. I was just trying to run it locally so we could see changes, but that will have to wait. Okay, so in this app, basically what happens is we have a chatbot. The chatbot is built using Vercel's AI package that gives us like some very helpful utilities that, again, I'm not going to go into in great detail. But there are some things that are happening here that I think are worth talking about. So there's one thing that happens here where we basically have like messages going back and forth between the front end and the back end. Again, without going into detail, basically every message that the user types in gets sent to the back end, and then messages that come in from the back end get sent to the front end over streaming. This is the route that deals with the back end basically responding to those requests. And we'll just go through the code to see what exactly is happening here. So before we start the process, if you saw very briefly on the right, there are 3 topics that you can click on and sort of see, and they will basically take content, basically crawl content from the web, and then basically create embeddings for it, and then save it in a Pinecone index. So that basically happens here in this route, in the seed. So I get past a some URL. I split or chunk that content from the URL that I crawl. It's worth mentioning here, and just like following up on the conversation that I saw in chat before, there are several methods of chunking your data. One of them, and I think the most simple, is indeed like the recursive method. But I think that it kind of it leaves a lot to be desired in a lot of situations. And I found that another method may produce much better results if, and this is a big if, you are able to convert your content into Markdown. If you have HTML content, this is very easy to do. If you have PDF content, it's also pretty trivial to do. The reason why this is a good method is because Markdown in and of itself has a lot of semantic information within it. It basically takes into account the way that the text is segmented by the author. So like if there are paragraphs, if there are headings that communicate, breaks in the text, those get into account, and for the most part produce better results. Definitely if there's code involved, code segments are usually kept together as opposed to being broken apart. So if you're trying to build a chatbot that would give back responses regarding a code base, you're better off using this method. I see that there's a hand up. Maybe we can take that question, Vijay.
I think you can go on, Roy. Yeah, we're answering. We have a couple questions in the chat here.
Okay, cool. Okay, and so after we create this splitter, we basically split those documents using that splitter, and then we vectorize here all of these documents, and then we chunk, and we basically take these vectors and insert them in chunks into Pinecone. There's some limitation to the amount of data that you can upsert into Pinecone with each operation, and so this just takes care of that for you. And then once that process is complete, we give back the responses in this area of the code. So this is get context. So get context. So again, we take the user's last message and we call this function, and let's go look at what it does. It basically gets the embeddings for that message. It gets the matches for that embedding, and those matches have some minimal score that we're looking to get. So basically, I'm not just saying like, give me the top 10. I'm also expecting the quality of the match to be of a certain level. So if I get like if I get like 3 or 5 or 10 documents, whatever it is, that are a very low score, I might not want to actually return them as a result, because they're sort of meaningless and they're just going to return bad results. So it's important to note, right, like that, a vector database will return all of the matches it finds with a score. It doesn't necessarily mean that all of the matches are going to be correct or accurate. It depends on your subjective sort of decision on what a correct or accurate score threshold is going to be. And then once I go over these documents, I basically return them back to this context. And exactly like Giuseppe's application, I do some massaging of the prompt, some prompt quote unquote engineering, and I basically force the LLM to respond based on the context that I provide it with, and nothing else. And now I'm going to very quickly go to the live version of this app. So maybe we can ask some questions until I'm ready to do that, because I think it's worth seeing this app working.
Yeah, some people asked where to find the code. Is it on GitHub?
It is on GitHub. It's also on Vercel. It's called the Vercel Pinecone template. It's very easy to find.
Is it the Pinecone Vercel starter?
Yes, the Pinecone Vercel AI SDK starter. Yep, yeah, that's it.
Perfect.
Let's see if I can access that real quick.
Then I think I found it and I can put it in the chat here.
Yep. Where's my here? Okay. Okay. So I can ask a question, for example. Let me just make sure this works. This is going to say hi back to me, right? Yes. Okay, so I have 3 topics here. One of these topics is about this athlete whose name I can barely pronounce, so I'm not going to try and do that. And I'm going to ask a question before I index about his salary. So I'm going to say, tell me about, let's see, spelled his name? No. Salary in 2023. And ideally it should say, yep, I don't know the answer to that question. And then I click on that topic. Now it's going to crawl, fetch all the information, embed it, and then insert it into Pinecone. Right. Might take a second. Please tell me this isn't dead either, because that would be very, very sad. Yeah, we're going to give it 5 more seconds, and if not, then we're going to call it. There's an error here. I'm going to... Yep, there is an error. Okay. Well, demo gods have been not kind to me today. I apologize for that. Let's call it. Oh, there we go. Thank God. Okay, so now we have all of these chunks that basically were created as a result of indexing this particular page that I have preset up in there. And so we'll ask the question again. And now we see that like the answer is right here. And it should be highlighting some stuff for me, and there's probably some slowness on the Vercel side, but ideally what will happen is that some of these segments will be highlighted based on the ones that are actually participating in answering that question. But yeah, that I think will do it for me.
Cool. Okay, we are at the top of the hour. Antje, were there any, I guess, common questions? We'll post the recording to youtube.datascienceandaws.com. We'll get that notebook from Giuseppe, post that on the Meetup as well.
Yeah, I think a lot of general questions. I think the space is just evolving so fast, and people are at different levels, of course. So I guess we're going to have a couple of more rec sessions maybe in the future, meetups to address. We also kept track of all the topics you suggested in the beginning. Thanks so much for sharing that. I think there was a trend towards knowledge graphs to understand that a little bit better. Any specific questions for Pinecone? But I think, yeah, for how can we use Pinecone on AWS? You folks are on the marketplace, right, Roie? So I think people can access it there.
Yep.
Perfect.
Yep.
All right. Let me see. I think that's pretty much it. Chris, do you see any other questions here?
I have one question, Roy. This has been coming up recently. The size of the embedding vectors, like what are the typical sizes of those? And is there a pro and con for larger vectors, like 4096 or 2048?
No, I mean, I think that typically what you see is 1536 is what I see the most. But like there are smaller sizes that are as much as performant as any. I think that like really it's mostly about like your use case. And so like the difference between using Ada 2, which is I think 700 and something, and using OpenAI's like later model, which is 1536, is negligible in terms of accuracy. And that just means that like, someone, went and asked some questions and had some, predetermined answers and then just compared. And again, in that context, the accuracy was not that much better. For Pinecone, it doesn't matter in the sense that, like we don't really care what you use. You can use whichever. Of course, the bigger your embeddings are, the more space they're going to take. And so, for example, if you're using the starter part of the starter plan, which only limits you up to 100,000 vectors, you're going to be more limited the bigger vectors you're going to use. You're going to have less vectors to use within that context. If you're on the standard or enterprise plan, you probably care less about this. And so, yeah, like I think that like at the end of the day, people tend to use overly strong embedding models when they're not really necessary. They're more necessary on the side of the LLM and the generation of the actual answers.
Gotcha. Yeah, because I've seen some models as big as 4096, and my thought there was more is better, right? But I guess
the question is how much better, right? Like if you're moving the needle from like, it's like 94.7% to 95%, it's great, but like what is the price that you're paying versus like the performance gain that you got?
Got it. Okay. Yeah, great stuff. And I think there's some people asking about like how do you do this on like AWS? Obviously, Pinecone is part of the marketplace. We do have some support in the AWS in like the Open Search as well. Has like an embedding store as part of it now. And also I think even our RDS Postgres, I think.
Yeah, you use PG Vector in Postgres RDS.
Yep. Yeah, RDS.
Somebody even brought up Kendra as an option too. Kendra's an interesting one. I put a link in the chat for how you could leverage Kendra if you're already kind of using Kendra as a document search mechanism. It takes away the need to do the embedding vector because it kind of does all the work.
That's right.
So you just pass the query into Kendra. Kendra provides documents back, and now you don't have to do any of the embedding work.
Is there any open source option, Roy, for Pinecone, or users need?
There's not. Pinecone is closed sourced and proprietary and all of that jazz.
So all you need though
Um,
is an API.
but-
We could start.
Yes. There's obviously, like, pros and cons. I would say that the biggest pro is, again, like what we're built for scale, right? Like, and if you've used PG Vector or Elastic or any of the quote unquote bolt-ons, you'd know that they might work up to a point, but then there's like a price to pay that comes on the other end, for the most part.
And then how do you? Yes, why don't you go ahead?
No, real quick. For some developers here asking what's a good resource to get started with Pinecone and where to get support. I think you guys have a community forum, right? Is that the right place?
Yeah, there's two places. We have a really extensive learn section in our website. It covers like everything we talked about here and then some, in really great detail. There's like tons and tons of video content created by James Briggs, our illustrious DA. And then there's also the community forum, like you mentioned. For sure, reach out there. And
I plus one the learn content on Pinecone. James Briggs is actually how I got started with RAG a couple months back, when I started really digging into it. The videos are fantastic. He's super, super bright.
Yeah.
Yeah, and then also, what else? Deep Learning AI just launched I think it's more around like semantic search and things you can do with these vectors stores. That's a short course that Deep Learning offers. So that I think that was by the like Cohere folks, but there's certainly no shortage of like ways to do things. It's just trying to, I think, work through some of the chunking, hyperparameters, if you will, like and trying to not stuff too much into your prompts, and you have to know the input context window of your LLM and be conscious of that. And so there's some nuances here, and I think re-ranking comes quite a bit too.
100%. I feel like the one thing that I've noticed again and again and again that people are doing is, well, maybe three. One is overstuffing their prompt, like you said. And that's due to the second thing, which is you just rely on the RAG results come back, like the retrieval results are coming back, and you're like, okay, I'm done, right? I think you're not, right? Like I think that like at that point, like you can still do a lot of things that are intelligent to like even improve on what you're actually sending like the model, and not expect the model to just like magically know exactly what to respond based on your retrieved content. But even maybe more importantly is like, what do you do with the query, right? For like the most part, users will ask you things that are just bizarre and unexpected, and your model, your data, like your knowledge base, right? Even if it's like pretty big, won't know what to do with, right? So there's like work that needs to be done around query comprehension and expansion, to actually make these queries matter, and be effective.
Giuseppe, I saw you were back and forth with someone asking about specifically a COVID-19 kind of use case where if the LLM's knowledge cutoff, right, I think is the term, was trained before COVID, and now all of a sudden you're using that LLM to try to reason through terms like COVID-19, which the model had never seen before, 2020 or whatever, right?
Mm-hmm.
So what was your thought? I think that's what the person was, getting at.
Yeah, I think that's where, it's almost like a garbage in, garbage out, where if you don't have anything good to provide to the model, it can't just make up a comprehensive answer. You really need your corpus of documents to house the context of the challenge in there. Like we talked about, how is Amazon affected by COVID-19? And you just have like a random mention of COVID-19 in there, you're going to get a garbage response back. provided that the model has no idea what COVID-19 is.
Right. Because it's almost like the vocabulary has expanded, and the LLM, because it was trained before COVID, might not know some of those things. But
yeah, I think kind of what you're going to get out of it, if you provide good context, is it will be able to use its just understanding of language to figure out that COVID-19 is something that you're asking about and connect the dots for you based on the quality of the context. And that's how you get a good response out of it.
Yeah, I really think it's a much healthier way to like think about LLMs. It's kind of like a natural language interface, you know what I mean? And not like an oracle or like a magical box that could just like do things for you.
that like knows every single piece of information.
Right.
Yeah, I think it was Jay Alamar from Cohere. I saw one of his talks in Toronto recently, and he said, stop thinking about the LLM as a database, like we already have those. And so think of the LLM as something that like understands knowledge. Understands language. You will never be able to keep this thing trained on all the latest and greatest. You have to go to RAG at some point. That was a big eye opener for me. Cool. Okay, I think we're probably over. Antje, should we wrap it up? And hopefully we'll see you all.
Yeah, let's wrap it up
Next month. Thanks, Roie. Thanks, Giuseppe.
Well, thanks for having me. Appreciate it.
and thanks everyone for
Thanks
joining.
so much.
We'll post this to YouTube here in a bit. So
Thanks. Bye-bye.
Bye.